Hey guys, your boy Chili. Welcome back to Reflective Serialization. This might be the last video in the series, I don't know. But it should be a fun one if you like masochism, template metaprogramming. Okay, so in the last video, we finally got the reflection in here, and it's amazing because it allows us to automatically let the compiler generate the code for serializing every member of a structure, which is great because that can save us a lot of busy work, and it can also save us from shooting our dick off. Now, the only thing that is kind of, bittersweet is we still have to manually list all the structure types that we want to support for serialization. And that's okay, because at least you can't shoot your dick off. If you forget to list one, the compiler will definitely tell you about it. So that's good. But it's still a bunch of busy work, and it's still, I don't know. You see, the thing is, it shouldn't have to be that way, right? Because what serial is going to do is it's going to look inside the serial namespace for a function, serialize, this one, that matches the thing that's being serialized, the type. So if we just make a template function that could match anything, any structure, then theoretically it should just use that one for every structure. And if we use reflection, it should be able to handle any structure. So that should work, right? Well, let's give it a shot. In the namespace serial, we put the serialize function that works for any type S, which is going to be our struct that we want to serialize, right? And in these reflections, so any shape of any struct with any kind of members, data types, names, it'll all work, right? Okay, so it didn't like it. Serial is throwing a static assert, and it's saying, no dog. The problem is now I found more than one compatible function for the provided type and archive combination. So basically, it's finding multiple implementations for a single type to be serialized, which makes sense. It provides a bunch of ones out of the box, so those will match, plus our unconstrained template will also match. You found two matches. That's not good. That's ambiguous. So you can see here the problem it's having is with chillnet command, and you might say, well, that's not a type that it supports natively. That's our type that we defined. Well, yeah, but it's just a std variant, right? Which they do support. So they're finding two ways of serializing variant, and they're saying that's no good. So what can we do? Well, if we constrain this template, we can get it to work. But how to constrain it? One way you could constrain it, which will work, but we wouldn't like it. So we can do requires std same as, let me just using namespace chill in here. So let's require that it's either a title command, a move command, or a vec2f. So we're basically whitelisting these three things, and everything else won't work. How about this now? So this does compile, and it works, but it's not really any better than what we had before, right? We still had a manual list of types that we want to support for serialization, and now we have a manual list of types just in different form. So this isn't good. So whitelisting all the types that we want to support isn't going to be good. But what if we could somehow blacklist all the types that serial is already natively supporting, and then anything beyond that will be handled by our template function? That's what we really want to do. Now, in my quest to figure out how to do just that, I was looking at the serial implementations for the various types it has. And they're not that complicated, like they're not that long here. And what you see here is you see Safine, which is the same thing as basically what I did with concepts down there with the requires, is they want to enable this if is input serializable binary data. So what does is input serializable do? So it's going to count the serializers, and it needs the value, the number of functions that can serialize this thing has to be exactly 1. So that's interesting. So what I thought I would like to do, only enable this function if it's not already serializable by serial. Now, the problem in doing that, so if we want to check is not not is input serializable, it's going to basically have to instantiate all the functions that could be serializable. And when it instantiates them, it's going to check, is it not input serializable? And that will instantiate, and that will check, and that will instantiate. It spawns a recursive compiler vortex into hell. It's not good. It doesn't work. So the next thing that I went for is, okay, well, we can't check if it's not already supported by serial because that is just does an infinite recursion. But there are a finite set of structures that are supported by serial, right? Like std string, std variant. That list doesn't grow. It doesn't scale with n, where n is the size of your own program. It's a fixed list. So what if we just blacklist all the things, manually blacklist all the things that serial already supports, and then what we're left with is anything new, anything that you define that you want to serialize. That should work, right? So let's do a little experiment. Let's try that. So we want to do something like, not std same as, so s should not be the same as std vector. No, that doesn't work because this is a type, this is a template. Oh, so what we really want to do is we want to blacklist all instances of some specific set of templates, because most of the stuff from the standard library is all templates anyways. How do we do that? Well, really we need to create a new concept to detect if a specific type is an instance of a specific template. So the way you do this, you write your own kind of type trait. And type traits detection typically works by template specialization. So we define a base template, a base case that covers everything that matches this, wide net. So the wide net is any template that has any number of template parameters plus a type named t. That's the thing that we're going to check to see if it's an instance of this template. And by default, we say it's not an instance. So how do we detect when it is an instance? So we specialize the template. So now this specialization is going to take different parameters. It takes the same template argument, but now instead of a type name t, it is going to take in a type name ... which are the arguments to this template that would get you a t. Is that interesting? Let's take a look. How does that work? Well, it's a specialization. So we need the same name. And then we need to say, how do these parameters fit in to these ones here? Well, the way they fit in is the first one just passes directly because it's the same signature, right? It's the exact same. The second one, it needs to be templated on args. And if we can match this pattern, then this type, which is instance of impl, is going to be a true type. But if it doesn't match, then it's going to be a false type. So what this means is, like, let's say we give t is equal to std vector int, and template is equal to std vector. And so then we say, okay, is there some args where if we do std vector of args, we get std vector int? And there is. The args is int. So with an args of int, that will match and we'll get a true type. Now imagine you put in here, again, std vector goes in here and std string goes in here. So is there some args where if you template std vector, you get a std string? No, you can't template. Vector of car is not a std string. Vector of nothing is a std string. You can't get a std string from that. So it would not match, and it would be false type. And there you go. That is basically how a lot of the template metaprogramming boils down to that. That's a big component of template metaprogramming for sure. It's one of the biggest sticks you can hit something with. And now, because I love concepts, I love new shiny thing, we will rewrite this as a concept. So is instance of is just equal to is instance of impl template t value. So the value, true type and false type, they have a member value. and you can return that. So now we have is instance of. I don't think I reinvented the wheel there. I don't think that's actually in the standard library, but it's very useful. So now we want to say not is instance of std vector s and not instance of std variable and not, we'll just use same as for std string because I'm not going to use w strings in my things. I'll just say that right now. So vector, variant, string, I mean that's the only ones we use, right? String, variant, vector. Yeah. So if we blacklist these ones, then for everything else it should just be R types and it should work, right? Ha 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 ha, no. No. You're doing template metaprogramming. It's never going to be that easy. So the next thing we find is, oh shit. It's trying to serialize int and it's trying to use our function here. It's like, we don't want to do that. We don't want to use this for anything that's not a structure. So why don't we blacklist everything that's not a structure? So std is class v can allow us to do that. It works for both classes and structures. So let's blacklist everything that's not a class plus instance of these class templates. That's just my dumb. It's not, it has to be a class type. We want to blacklist anything that's not a class. So it's got to be is class. Just got my logic flipped there. Okay, try again. Ha 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 ha, no. Now it says it could not find any input serialization functions for the provided type and archive combination. So now it's saying it can't find any way to serialize a basic string. That's very weird. What do you mean? You have a way, like there's a way, you can do it. Why don't you think you can do it? And this one took me a while to figure out. I don't even remember how I got the brainstorm to guess it. It was not ChatGPT. ChatGPT did not help me out here. I tried, but it's pretty useless with template metaprogramming, I'll tell you that. Not completely useless, but fairly useless when you get anything beyond the basics. Now, I started looking at what it's doing for string, and I noticed that when it is checking to see is output serializable, it doesn't check char_t, it checks binary data of char_t. So it's doing something with this binary data type. And I was wondering, okay, well, this is an internal type to serial. What if I try also blacklisting this one? Does that help anything? So that's fine. This is also a template. So let's do and. So let's do and not is instance of binary data. Serial binary data, but we're already in the serial namespace, so it's all good. So S is not an instance of binary data. Now, funny enough, that does it. There you have it. So now we have a serialized function that will work for any type we create. Any new one, we don't even have to do anything to try to register it with serial. It just automatically knows how to serialize everything just by magic. Now, there is a little bit of a problem with this. Well, there's an annoyance, and then if you think about the annoyance, you realize it's a bit of a problem. The annoyance is obviously you have to now blacklist everything that serial can possibly do, which it's like everything in here. So array, atomic, bit set, boost variant, chromo, complex, deck, for list, like all these things. It's not an enormous list, it's just mildly annoying. Now, the more annoying part of this is, in order to blacklist these, they have to be defined. So now we have to include everything. So variant, optional, forward list, even though we might not be using it, we have to include it and compile it, which is kind of trash, right? Especially since we're probably not going to be using half of those. I mean, that's one option. Another option is just to add them in here as we're using them. But that's annoying, right? If you want to use something new from the standard library, it's going to cause a compile error for serialization until you figure out, oh yeah, I got to put it in this list here. I got to add it to the list. So that's annoying. It's not a game stopper. It's not a showstopper. It's annoying. So is there a way that we could do it without blacklisting one by one? And there is. So essentially, anything that lives in the namespace std or anything that lives in the namespace serial, we don't want to attempt to serialize those with our template. So if we can detect the namespace that a type lives in, we could do this much more cleanly. Now there's no, that I'm aware, there's no like type trait or anything that lets you detect the namespace. This is probably doable with the reflection proposal I showed you earlier, but we don't have that. We don't have the good stuff. So can we detect the namespace? We can, but it's technically, it's a little bit of bad mojo because it requires us to inject a little thing into the std namespace, which you're not supposed to do, except under very specific circumstances. But we're going to do it anyways because, I mean, realistically, it's not going to blow up, and it makes our life easier. So let me show you how to detect if something is in the std namespace. So like you do, you use template specialization. And we got a type name t, and then we got another template parameter that is defaulting to void. And that's called isMember of std, and it is defaulted to false. That's how you do it, right? Now, what's the specialization? Specialization takes in only the t, and it's trying to instantiate isMember of std with t, and it has to fill this second parameter. And the way it tries to fill it is to do decal type of calling this function with a value created from type t. So if this bullshit fails because it doesn't work, then it's not going to blow up your compilation. It'll still compile, but this will be removed from the list of candidates, and this one will be used, which means you'll be false. However, if it is able to do this bullshit, then you will get true. So what is the bullshit? Well, it's going to try to call a function, and that function is going to be put in the std namespace. But we're not calling std blah blah blah. But there's a little thing in C++ called ADL, argument dependent lookup, which means if it can't find this thing in the current namespace, it's going to look at the namespace of the argument. And if the namespace of the argument is std, it will look in the std namespace for that thing. Which means that we can use that to detect whether t is in the std namespace, because we didn't put a std here. So the only way it's going to find it is if t is in the std namespace. You catch me? That's a little tricky. It's a little tricky. And so, doing this, we can check to see if any type is in the std namespace. And then while we're at it, we can create another one that checks if a type is in the serial namespace. We have to do this for every namespace we want to detect, unfortunately. We can't like template it on the namespace. That's not a thing you can do. As far as I know. Maybe, I don't know. You can do lots of crazy stuff that I'm not aware of. Now, let us create a concept template, class S. Concept is not natively serializable. So it's not natively serializable if A, so anything that's not natively serializable has to be a class. Because if it's not a class, then it's like an int or an enumeration. That shit is all already serializable. So it's not natively serializable if it's a class and it's not a member of std, because everything in std we're going to assume is natively serializable. And it's not a member of serial. Because as we've seen, some things in serial they got to be called on the serialize. It's just the way it works. So there's our concept. Is not natively serializable if it's a class and it's not in std and it's not in serial. So if that's the case, we can put the concept, because of the way we wrote it, we can put the concept right in here. So now instead of class S, it says is not natively serializable S. So this template only matches things that have an S that is not natively serializable. And then it'll do this stuff for it. And everyone will be happy. And there you go. It builds. Beautiful bastard. And it works. It's a beautiful thing. You love to see it. And I mean, I don't know how many times I gotta hammer the point home. But again, anytime we change the contents of these structs, we don't have to do anything. the system automatically just adjusts to how it serializes. And anytime we add new structs and start to send them, again, it just works. Everything just works now. Isn't it beautiful? But yeah, that's the power of, well, a nice mature serialization library like Serial, and B, combine that with some slinky dinky reflection, and you got yourselves a winner here. Now, my one caveat is this reflection is kind of built, like I said, it's built with like duct tape and shoestring. It's a little sketchy. I'll still use it, but you gotta have a little sense of buyer beware. And the thing is, once we get the real shit, like this shit in here, I mean, first of all, it's not going to be nearly as sketchy to do this kind of stuff. But second of all, the stuff you'll be able to do is like way crazier and way more powerful than this stuff. You can do a lot of stuff. And I've used this reflection for example, logging, for dumping structures. Like instead of manually typing format strings to format out like a structure that has, like, I don't know, like with nesting included, maybe like 100 members. And I could do it with a kind of reflection in just a single line of code. And that's great because I don't want to waste my goddamn time. It's great for serialization like I've shown you here. It's great for a bunch of things that I haven't even, brushed up against yet. But, yeah. People ask me whenever I'm excited about reflection, they're like, well, I don't understand what you can do with it. Well, this is what you can do with it. And as I've shown you, this can save you a lot of bugs and a lot of monkey code typing for no good reason. And that's worth a lot. So I think this is the last video in the series, unless I could think of one more, but I think probably everyone's appetite has been sated at this point. And the one that I'm thinking of is kind of crazy. So yeah, that's it. That's it for this. Thanks for watching. Hope you enjoyed until the end of the whole series. That's cool. Click the like button, and I will see you again with some C++.